Hi, today I'd like to talk a little bit about automated technologies for in-row weed control. My name is Mark Siemens. I'm in the Biosystems Engineering Department with the University of Arizona. So what are in-row weeds? In-row weeds are the weeds in between the individual crop plants within the seed row. These are highlighted in yellow on your screen. Weeds between the crop rows, we can use standard cultivators and cultivating tools to remove those type of weeds. But it's the in-row weeds that are difficult to control and is the focus of this talk. Hand labor is typically used to remove these weeds. It's labor intensive and it's expensive. The reason we use hand labor is unlike other crops, we don't have selective herbicides that we can use post-emergence to control in-row weeds. There are automated in-row weeding machines that are commercially available. And these have actually been around for quite some time. They were first commercialized in 2008. These machines are primarily coming out of Europe, where labor costs have been high for a long time. And the type of machines are typically utilize mechanical blades to remove in-row weeds. There are 4 automated in-row weeding machines that are commercially available and utilized in the Yuma area. All the machines operate principally the same. They utilize a forward down-looking camera to identify crop plants and some sort of mechanical knife or blade to remove the weeds in between the crop plants. In the case of the Robovator, it utilizes a cultivating disc assembly, and as the machine travels through the field, this disc blade rotates around the crop plants, cultivating the weeds in between the individual plants. Throughout this presentation, I've embedded some videos, and they should be self-explanatory. Another of the in-row weeding machines is the Steketee IC. This machine is manufactured by Steketee out of the Netherlands.
Speaking of an eagle's eye, this is it. Inside the IC there are cameras shooting high-resolution images from the crop. A computer translates these images, ordering the knives to do their job. Now, the raw images from the cameras would only let you see what you and I see when looking at a field. But now watch this.
The dedicated software in the onboard computer creates a whole different image. It makes the perfect distinction between crop and weeds. The IC distinguishes different colors of the crop, ranging from yellow to purple. And within a nanosecond after analyzing the images, the weeding blades will know exactly what to cut or to save.
Oh, look at this. It's beautiful. IC has taken out every single weed between the crop. Beautiful.
The IC is tough on weeds but goes soft on your plants. While cutting weeds, the IC with a puff of air gently blows off the sand that has fallen onto the plants. A unique feature indeed.
The RoboVator is a machine that's manufactured by Frank Poulsen Engineering out of Denmark.
Here, the weeds within the lettuce rows are selectively cut from between the individual plants with cultivator blades. Fix-mounted goosefoot shanks weed between the rows. Digital cameras record the position of the lettuce plants in each row. A freely turning wheel equipped with sensors on the back of the implement transmits speed and working depth data. With this information, the computer in the cab digitizes the identification of the crop plants in the rows and converts the data into control signals which cause the cultivator blades to move around the plants. Thanks to the onboard electronics, the height control and sideways steering of the entire implement are fully automatic.
I think the previous slides pretty well explained how these machines operate and function. The machines are pretty expensive, typically about $200,000 for a 4-row machine. And that's a pretty significant capital outlay for growers. I was involved in an experiment about 3 or 4 years ago where we were evaluating the performance and cost effectiveness of these machines as compared to standard cultivators. So we compared the conventional cultivator with the RoboVator in different crops: broccoli, iceberg lettuce, and romaine. We conducted 5 different experiments in California and Arizona. The results are shown in this table. The number of weeds per square foot before and after cultivation. So we looked at comparing the cultivators with in plots treated with and without pre-emergence herbicide. So when we had pre-emergence herbicide applied, we had low weed pressure and essentially no difference in cultivating techniques. In the trials where we didn't apply herbicides, we had high weed pressure, and in 4 out of the 5 trials, we had significant differences in the performance of the cultivator, the conventional versus the automated in-row weeding technology. In a couple of these trials, we had excessive weed pressure. 45 weeds per square foot is not very realistic. You can see the amount of weed pressure we had in this slide: pre-cultivation and post-cultivation. The positive thing about having high weed pressure is we got some pretty informative information about the performance of the in-row weeding technologies. What we learned was the in-row weeding technology controlled about 2/3 of the in-row weeds. If you look at the numbers kind of generally in the first column, you can see the conventional cultivator had about 15 weeds per square foot after cultivation as compared to the RoboVator with 5. That's a factor of 3 to 1. So therefore you can conclude that about 2/3 of the in-row weeds were controlled. Another way to look at this or explain it, if our spacing between individual plants is 12 inches and the diameter of the plant is 4 inches, the distance between the leaf edges of the crop plants is 8 inches. And so if you take 8 divided by 12, it equals 2/3, which makes sense. Of course, the objective of automated in-row weeding is to reduce our reliance on hand labor. So in 3 out of the 4 trials, we noticed significant differences in the amount of hand labor required. There was no difference in plant population or crop yield. So what we concluded from this experiment was fairly obvious and common sense. Basically, when you have high weed pressure, the automated in-row weeding technologies are a benefit. They reduce labor and depending on cost, could be cost effective. When the weed pressure is low, there's really no benefit to using the technology. So basically we have commercially available machines to control the weeds circled here. But how about this guy, the weed close to the crop plant? These are the 1/3 of the weeds that we're seeing from our experiments that the automated in-row weeding technologies don't control. Developing automated in-row weeding technology to try and remove this remaining 1/3 of the weeds is very difficult. People have been trying to do this for decades and still are. What I'd like to do is highlight some of these technologies in development that are particularly relevant to our production systems here in Yuma. The first of these is Robotti. It's an autonomous dual carrier. So it's essentially an autonomous robot designed to carry different implements from seeding all the way through eventually harvest. The way the company envisions using this autonomous robot for weed control is to first apply a pre-emergence herbicide. And here in a band, once the crop has emerged, a second band spray is applied. The next operation would be mechanical tillage. So the concept behind this technology is multiple passes with a small autonomous robot that would operate 24 hours a day. AgroIntelli actually did demos here in the United States last fall. They received input from growers from those demos and are coming back or plan to come back this summer with a 150 horsepower autonomous tool carrier. This is some research work being done out of the University of Sydney.
We tried out these new machine learning algorithms which allowed us to speed up the whole learning process. So we want to be able to go through and have Ripper traverse over a number of different rows, identify the plant, and now Ripper knows that plant. It can now target and spray that individual plant.
Spraying brilliantly now.
And what that would do is dramatically reduce the amount of chemicals, and that would be a game changer, because if you could do something like that, then within a space of a few hours you can go to any farm anywhere around Australia and all of a sudden Ripper will now know, okay, this is the crop that I'm most interested in.
Out in the paddocks, Swagbot has to learn what a weed is. Here, Ripper learns what the crop is, and everything else is weed.
It's firing away, it's doing really
Now
well.
it can decide on the spot what to fertilise or eradicate. Or it can activate its vacuum or the mechanical weeder, all that while moving along.
Not bad, since it's only learnt about broccoli yesterday.
It's pretty impressive what those algorithms can do. Collect some data, train them up, and that's it. It knows broccoli now.
Yeah.
Deep Field Robotics is a Bosch startup company. They've been around for some time. it's weed sniffer or weed snuffer. They've since switched direction and came up with
Huge
this
amounts
sort
of image
device.
data obtained in the field are the foundation of a new type of plant identification. It means that weeds can be reliably identified and removed. The new technology has already undergone practical tests with autonomous robots. It reliably works in various growth stages, with single robots or in a swarm. The modular solution, using a camera and artificial intelligence, differentiates between crop plants and competing weeds as reliably as humans do. While driving along the sugar beet rows, plants are analyzed in real time. Enabled by precise camera technology and machine learning, an intelligent software distinguishes crop plants from weeds and gives the correct signal for weed removal. Engineers used artificial intelligence to create this ability previously mastered by humans only. Plant recognition works day and night.
So this is some work out of the Mascar Institute out of Germany. So that was 2018. In 2019, they were a robotics award finalist at Agritechnica in Germany. And part of the reason I think they won this award is rather than that brush system you saw in the previous video, they partnered with a company called Zasso, which is using high voltage or electrocution to kill the weeds. So if you look at, I don't know if you can see my cursor, but it's in I guess the lower left-hand portion of the machine. This device precisely zaps weeds. Is using high voltage effective for killing weeds? Well, there's a company called Rootwave out of the UK that is promoting this. They partnered with several agricultural equipment manufacturers and small startup companies. Echo Robotics is a company out of Switzerland, and they have a pretty unique Delta Arm type weeding robot. So the previous video was 2018. In 2019, they've come up with actually two robots, one as a scouting robot for phenotyping, and then a second robot they're calling a weeding robot. They debuted their weeding robot in December of 2019. In 2020, they plan to test and work the bugs out of their prototype machine, and in 2021 begin selling units. A lot of people ask about laser weeding. This is some work conducted by Harper Adams University and led by Simon Blackmore. So I'm not exactly sure what's going on here, but I think if you look closely, there's like a laser red dot pointer, and I think they're using some sort of robotic control to position the laser onto the weed and get enough energy onto the weed to actually kill it. A company called Nio Technologies out of France is also investigating the use of laser weeding. They've partnered with a company called Green Shield. Some of you might already be familiar with Nio Technologies. They make an autonomous weeding robot. About a year ago, they came to Salinas and were operating in Salinas during the summer, and then around October moved operations here. The unit was demoed at the Southwest Ag Summit earlier this spring and was demonstrated on commercial farms throughout the growing season this fall. They've had some recent successes also. In 2018, they won silver medal at the Agritechnica for their in-row weeding tool. Another company that manufactures an autonomous weeding robot is a company called FarmWise. They've been operating in Salinas and Yuma also. At the 2020 Southwest Ag Summit in Yuma, Arizona, Agmetronics out of Silver City, New Mexico, showed their new in-row weeding machine. They had the main machine there, but they actually didn't have the working components. They did have some brochures available. This is the front cover of one showing what the machine looks like. And they say that they're close to commercially releasing it. They just have a few bugs to work out. This is the back side of the brochure. It's a pretty unique mechanical device. They're calling it a carousel type weeder. Another technique for non-chemical in-row weeding is using hot oil to kill the plants. In this slide, you can see the concept. Basically, streams of hot oil are delivered to weed plants, and the hot oil kills the plant. This work was done some time ago at UC Davis, led by Dr. David Slaughter. TensorField Agriculture, a startup out of Silicon Valley in California, is reviving this technology. You can see here the spray assembly, very similar to the one UC Davis developed, delivering hot oil to kill weeds. Their plan is to also develop an autonomous weeding robot that utilizes a machine vision system to identify crop plants and weeds. Similar to the other robotic weeding companies, they're also planning on using artificial intelligence and deep learning to identify crop plants and weeds. TensorField is a young company. They formed about a year ago and are attracting some attention. They were featured at TechCrunch in Sichuan, China in December. The company's built a prototype and plan on testing it this summer in Salinas. TensorField Agriculture was at the Southwest Ag Summit this spring. I'd like to switch gears here and talk about camera-guided cultivators. It's a technology that's been around a while. It was popular back in the 1990s prior to Roundup resistant crops. There are several companies making such technology. One of these is called Crest, and they're available locally through their distributor, Keithley Williams Fabrication. I don't have a lot of experience with guided cultivators and the in-row finger weeding tools that you saw in the previous video, but I do have some experience in cotton. Over the course of the last 2 years, we've done some experiments. The project was funded by I'd like to acknowledge them, as well as the significant support that we've had with industry called Crest and Keithley Williams Fabrication.
We got a nice temperature.
So what we're doing here I'm listening to Kim in the background, is looking at trying to control weeds in young cotton and seeing if the in-row finger weeding tools are injuring the crop plants. In the previous video, you saw some preliminary work where we learned how best to operate the machine and what its capabilities were. The goal of this project was to use automated technologies to control herbicide-resistant weeds in cotton. We looked at 3 different types of cultivators. One, a conventional Lilliston cultivator, as shown in figure 10, and then also a cultivator attached to a tractor equipped with GPS RTK. In this, with this cultivator, the cultivating tools left an uncultivated band of approximately 6 inches. The advantage of using guidance systems with cultivators is you can position the cultivating tools much closer to the crop row without injuring the crop. That is shown in Figure 8. We tested the cultivators with and without finger weeding tools on them, which provide some cultivation within the crop row. These are shown in Figure 7 and 9. Here are the results of the trial, and again, our 5 treatments. The conventional treatment, the uncultivated band was 10 inches. For the GPS RTK guided tractor, the uncultivated band was 6 inches. For the camera guided cultivator, the uncultivated band was 3.5 inches. These last 2 cultivators were tested with and without in-row finger weeding tools. We performed 2 cultivations and categorized weeds by type, broadleaf or grassy. What I'd like to focus on is the end result after the second cultivation. The results highlighted show comparison or effectiveness of weed control as compared to conventional. You can see the effect. Essentially, there was no difference with the GPS guided tractor. It was the same as the conventional cultivator. However, when the in-row finger weeding tools were used, weed control improved by about 40%. The camera guidance system with the narrower uncultivated band reduced or improved weed control further, only 42% as many weeds as compared to standard cultivation. Use of the in-row finger weeding tools also improved performance. So ultimately, you only had about a third as many weeds on the bed top as you would with standard cultivation. What I forgot to mention on the previous slide was that growers are starting to utilize in-row finger weeding tools in vegetable crops, and they're also beginning to explore use of camera-guided cultivators. This concludes my presentation. Thanks for your patience and attention. And if you have any questions, ask Barry. Or feel free to contact me at the email address on the slide. Thanks again. Take care.